Okay, the first half of 4.7 is going to be inverse trig functions. So we got a couple of examples that we're going to do, and this shouldn't take nearly as long as the previous videos. So hopefully you have your notes in front of you because it does have the different restrictions that I'm going to be referring to. All right, so arc sine of 1/2. All right, basically, what I'm trying to do is I'm trying to find the angle where this is true. So I'm going to, oh, I don't need purple. I'm going to go ahead and set this equal to some angle. I'll call it theta. So basically what this says is that sine of some angle theta is going to give me 1/2. So the first thing I need to ask myself is that even possible? Well, yeah, of course it is. The only reason why I say sit back and think about it is because sine does have a restriction on it. The highest that sine is going to go is 1. The lowest that sine is going to go is -1. So you just need to make sure that this number is somewhere between -1 and 1, which it is. This is totally viable. So what I'm going to do is I'm going to take out my little graph restrictions here. And then based off of my notes, I know that arc sine, or inverse sine, can only exist between -π/2 and π/2. So what I do is I completely cross off this area. I know I can't go through it, I can't land in it. Just as long as I'm not over there, I'm good. If I am, then I'll figure it out. So I want to know in these two quadrants where sine is going to be 1/2. Well, it's definitely not in the bottom either, because down there, sine is going to be negative. So let's color code that a little bit differently. So I got rid of that because I want the sign to be positive. So sine is going to be positive. Sine is the opposite side. So I visualize I want a short opposite side, which means I'm looking at about that radian. So to generate that angle, it looks like I'm going to be at π/6. So I think theta is going to be π/6, which means arc sine, my original question, of 1/2, that occurs at π/6. That's my answer. All right, let's move on to the second one. So arc cos, so whenever we have an arc on the outside, we're actually looking for an angle. So this says that cosine of some angle is -2. So I ask myself, is this even possible? No, this is definitely not possible. Cosine achieves a true minimum value at -1 and a true maximum at +1, which means it only exists between -1 and 1. This is not possible. So what I would say is that arc cos of -2, I know it looks funny with the equal sign, but it doesn't exist. It just can't be done. If it was maybe a different trig, sure, but definitely not cosine. All right, moving on. So I've got arc sine, so I've got an arc out in front, which means I'm looking for an angle. So what this says is that sine of some angle theta is going to be equal to -√3/2. So I ask myself, can sine be -√3/2? Yes, it can. -√3/2 is, what is that, -0.8 something, I think, or -0.7 something. So that's definitely between -1 and 1. This will work. Let's go ahead and take out our little graph. It started out as an arc sine, which means it can't be over here. Then I know this is going to be negative, which means it's definitely not up here. So out of these quadrants, I know that I want my sine to be negative, so it's down, and √3/2 is kind of tall. So I want that angle. Remember, it's got to be generated this way. So if it was in the first quadrant, I think it's a π/3. But in this case, I think it's a -π/3 because it's down. All right, so my answer to the question, I know that the question was arc sine of -√3/2, and the radian that I found that worked for this is -π/3. All right, number 4. Cosine inverse. Well, cosine inverse is the exact same thing as arc cosine. So I'm still just looking for an angle. So basically, I've got cosine of some angle is equal to -1. Is that possible? Yeah, that is actually the true minimum value for cosine. This one will work. All right, so let's take out a little graph. My restrictions. Well, from the notes, I know that arc cosine only exists between 0 and pi. So that means that I can't be up there. All right, now I take a look at this. Cosine is -1. Well, cosine is x, so that's to the left. So it's definitely not over here either. All right, so cosine is -1. Well, cosine's the x value, so if I take a look at this, I think I'm just going to be over here. So whatever that angle is, well, I think that angle is going to be pi. So I know that cosine inverse of -1 is just pi. All right. Number 5. So we've got arc cosecant. All right. Well, it's still arc in front, so I'm still looking for an angle. So that means that cosecant of some angle is supposed to be 2√3/3. Now, we have to do a little bit more thinking. So cosecant, based off of what we did in 4.6 with the graphing, we know that cosecant exists everywhere that sine does not, except for the extrema points. So sine exists between -1 and 1, which means cosecant exists beyond -1 and 1, but it also includes -1 and 1. So is 2√3/3 beyond 1? Yeah, it is. 2√3/3 is larger than 1. So this is good. If it was smaller than 1, I couldn't do it for cosecant. All right, so beauty of cosecant, it's the reciprocal of sine. It has the exact same restrictions that sine does. So go ahead and take out my little picture here. I know that sine has the restriction, or arc sine, has the restriction, where it's between -pi/2 and pi/2. Well, so does arc cosecant. All right, so now I see that cosecant is 2√3/3, which is positive. Out of these two quadrants, it's not positive down there. So my knowledge of this, well, I'm not a big fan of cosecant, or actually of secant or cotangent, but I love the original functions. So if I flipped this over, 2√3/3 would become √3/2 for sine. So I'm looking for a tall sine value. So I think that angle is going to be pi/3. All right, so my question. So I've got arc cosecant of 2√3/3, and my angle was pi/3. All right, number 6. It's got an arc in front of it, so I'm still looking for an angle. So that means that tangent of some angle is going to be -1. Does this work? Well, of course it does. Tangent and cotangent can be anything they want. There are absolutely no restrictions on it. So you could get tangent theta is equal to 52. That's okay. So I'm good with this one. Let's just go ahead and get our little sketch out here. We do have the restrictions for arc, though. Now, arc tangent has the exact same restrictions as arc sine, so it can't be on the left-hand side. It has to be from -pi/2 to pi/2. Then I take a look at this. It's -1 out of the two quadrants that remain. It's definitely not up here because that's positive. So for -1, well, tangent is -1 when the sides are the same length. So I think we're looking right in the middle. So I think our theta is going to be -pi/4. So arc tan of -1 and our angle is going to be -pi/4. So some of the things to keep in mind, whenever you have an arc on the outside, you're basically looking for a radian at the end or an angle at the end. So I go ahead and just set it equal to theta. If it helps you to rewrite it, rewrite it. Always ask yourself, does it match the restriction? Like, is it even possible? Sometimes you're going to have questions that aren't even possible, so there's no point continuing. You just have to stop and think. Then if it is possible, take out the little graph with the restrictions on it and make sure that you don't land or go through the areas that are unacceptable.